Hello everyone, welcome to the channel. Today's question is counting bits. If you are new to the channel, please consider subscribing. We solve a lot of interview questions on this channel and that can definitely help you with your interview. The question says, given a non-negative integer number num, for every number I in the range 0 less than equal to I less than equal to num. Calculate the number of ones in their binary representation and return them as an array. And if you look at example number 1, we are given with 2 and we are returning 0, 1, 1. And if you look at example number 2, we are given with 5 and we are returning 0, 1, 1, 2, 1, 2. So let's move on to the coding part and let's understand what these examples are saying and let's see how we can solve this question. After that, we will see the code. I have taken the example given in the question. So let's first understand what exactly question is saying. So when question is saying 2 and output should be this way, that means starting from 0, it says when I am representing 0 in binary form, I have 0 is the number of ones in binary representation of 0. And when I am talking about 1, 1 is the total number of ones in binary representation of 1. And when I talk about 2, 1 is the number of ones in binary representation of 2. If I talk about number of ones in 0 is 0. If I talk about number of ones in 1 is 1. If I talk about number of ones in 2, that is also 1. If I talk about numbers of 1 in 3, so I have 2 ones. If I talk about number of ones in 4, then I have 1 4. If I talk about number of ones in 5, then you can see I have 2 ones. And this is what I am representing in an array. So before we see how we can solve this question and what is the intuition behind it, let's first talk about two things. One is least significant bit. Least significant bit is the rightmost bit of a binary representation. It will define whether the given number is odd or even. If the LSB is 0, that means the given number is even, and if it is 1, that means the given number is odd. And the another thing is right shift. And if I say right shift by 1, that means suppose I say I took 7. If I make a right shift by 1, that means it will become 0 0 1 1. That means we will drop this 1 and we will add 0 in front of this. In general, when I am making a right shift, I am dividing the number by 2. So if I divide 7 by 2, it will come up to 3. And 0 0 1 1 is binary representation of 3. Let's take 6. 6 is equal to 0 1 1 0. And if I make a right shift, it will become 0 0 1 1. Again, this was 6 and this is 3. So making a right shift is equivalent to dividing by 2. Now we know both the things, what is least significant bit and the right shift. So let's see how we can solve this question now. So let me erase this for you. So if I say that I am given with any number and I need to return the solution in this form, that starting from 0 till the n, I need to represent how many number of ones a particular number have at every single position. So one way is I will take a for loop in n. I will come to 0. I will count number of ones in 0. Then I will come to 1. Then again I will count number of ones in 1 and so on. Then again, for that I need to go in the binary representation of every single element. And then I have to take 2 for loops, and the question is asking us that can we solve this question in O of n? So we need to come up with solution which is O of n. And what is the solution for that? Let's see that. So if I write down the number of ones from starting from 0 to 12. So I have written till 5. In 6 I have 2. In 7 I have 3. In 8 I have 1. In 9 I have 2. In 10 I have 2. In 11 I have 3. And in 12 I have 2. And if you see, we can see a pattern. And what the pattern is, let me show you in a second. For 0, number of ones is 0. For 1, the number is 1. For 2, again it's 1. For 3, it's 2. For 4, it's 1. For 5, it's 2. For 6, it's 2. For 7, it's 3. For 8, it's 1. For 9, it's 2. For 10, it's 2. For 11, it's 3. For 12, it's 2. If I take out any odd number, let's say 7, and I divide 7 by 2, and I will add 1 to that. 7 divided by 2 is 3, and the value of 3 is 2, and if I will add 1 to that, it will become 3, and the 3 is the value of 7. This is the case of odd. In case of even, I just simply need to divide by 2. So if I take 6, I will divide it by 2, and after dividing I will get 3. So I will simply take the value of 3, which is 2. So if I take 6 divided by 2, which is 3, and I will take the value of 3, which is 2. So you can see 3 and 6 have same values, 4 and 8 have same values, 6 and 12 have same values, because 12 divided by 2 is 6, and they have same number of ones in there. And if I talk about odd, you take 11. 11 divided by 2 is 5. The value of 5 is 2. 2 plus 1 is 3. So we can see this pattern over here, that if I have odd, then I need to divide it by 2 and need to add 1 to its number of ones. So that will gonna be my number of ones. And if it is even, then I simply need to divide it by 2. Then the number of ones in 8 and the number of ones in 8 divided by 2, that is 4, will going to be same. Alright, so let's see how we can represent this pattern in our code. So we are saying two things, that one is we need to divide it by 2. And I told you, whenever we make a right shift by 1, that is equivalent to divide by 2. And the second is we need to add either 0 or either 1. You can say in case of even, we are adding 0, and in case of odd, we are adding 1. So one is we need to divide, and one is we need to figure out whether we are going to add 0 or whether we are going to add 1. But again, the question is how I can tell whether the given number is odd or even when I don't know what the number is. So if I say that take any number, let's take 11, and the binary representation of 11 is 1011. If I take a AND of 11 with 1, it will be equal to 1 0 0 0. If taking AND with 1 and its end up equal to 1, that means the number is odd. Or you can say I will add this number to my n divided by 2. Let me say it again. Rather than get confused between even and odd, I can simply say that I will going to add AND with 1 of given number. That if I am going with 8, I will going to do 8 divided by 2 and I will going to add 8 and 1. This is AND operation. If I am given with 9, I am going to divide 9 by 2 and I am going to add 9 and 1. So let's see 8 and 9 example above. So 8 is represented by 1 0 0 0. I will going to divide 8 by 2, so which is 4. The number of ones of 4 is 1. Then I will going to add 1 0 0 and with 1. And if I take a AND of 1 0 0 with 1, it will come up to 0. Because in AND, to get 1, I need to have 1 and 1. So it will 0. So 1 plus 0 is 1. And you can see the number of ones in 8 is 1. And let's see the example for 9. So 9 divided by 2 is again 4. And so I will take 1 and I will add 1 0 0 1 and with 1. And if I'll do a AND, it will turn up to 1 0 0 0, which is equal to 1. So I will add 1 plus 1, that is equal to 2. And 2 is the value of my 9. So in this way, whenever I am given with a number, I will start with 0 and every time I will go back to divide by 2, and once I am done with divide by 2, I will add number and with 1. And whatsoever will be the return, either it will gonna be 0 or either it will gonna be 1. If the number is odd and whenever I will take a AND with 1, I will going to get 1. If the number is even, whenever I am going to take AND with 1, I am going to get 0. So this is the way I can solve this question. So let's move on to the coding part and let's see what is the code for this problem. So let's see the code. At line number 3, I made an array called result and I have initiated it with 0 at index 0. Then I'm taking a for loop and I'm simply appending result I right shift 1. When I'm saying I right shift 1, that means the value at I divide by 2. And I'm adding either 0 or 1. And I'm adding integer of I and with 1. And this will tell us whether I need to add 0 or I need to add 1. I and with 1 return 0 in case of even and it will return 1 in case of odd. And at the end, I'm simply returning result. So this was the code. Let's see whether it works or not. So here I submitted my code and it got accepted. So this was the solution for this video. You can find the code in the description below. If this video was helpful to you, please give it a thumbs up. Thank you so much guys for watching the video. Please don't forget to subscribe.